Good morning, guys. Am I audible?
Yes, we are. It's audible.
Thanks. Okay, just wait for 1 minute. Okay, guys. So let me share my screen. So Docker. My screen is visible, right, to everyone?
Yes, Freedom.
Okay. And by the way, so yesterday I have given some task, right, to so integration with SonarQube. Uh, any questions on this? Did you complete or any questions on this? Yeah.
No questions, Vira.
No question.
Oh, okay. So I hope you guys are completed this pipeline execution. So still, if you are facing any issues, please do not hesitate. You can ask me that I will explain. So take one more day if still anyone is pending. Anyway, once we discuss in the project execution time, we need to configure all the tools with Jenkins, right? At the time also we'll cover again this topic. No need to worry about here. Okay, so meanwhile, so far we discuss. Let me close. So far we discussed the tools AWS, Git, Terraform, Maven, SonarQube. Okay. And the very important tools are now Docker, Kubernetes, and Ansible. But Docker Kubernetes is very, very important tool for as a DevOps engineers. So we have to focus more on this area. So first of all, Docker is a containerization tool, guys. So containerization tool. Docker is a containerization tool. So let's understand what is containerization tool first. Okay. The simple logic here. So my client is asking me to implement 10 applications. So my client requirement is to deploy 10 applications. This is my client requirement. Okay. In this case, virtualization concept is nothing but if you want to deploy this 10 application in Amazon cloud. So if you want to deploy 10 applications into Amazon cloud, so Amazon cloud means cloud virtualization only. The concept they are providing cloud virtualization. So if you want to deploy 10 applications, so we need to create 10 servers. So we need to create 10 servers. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So 10 applications. So here 10 servers we have created. Okay. 10 applications we have created here, 10 servers. So app 1, app 2, and app 10. So 10 applications are running on your EC2 instances. 10 applications, 10 EC2s are running here. Ten applications, 10 EC2s are running. Okay, fine. So we can deploy each application in one server. We can give access to public or whoever looking access. But here important one is coming to the high availability. So again, we need to create one more 10 servers to get high availability. And again, to get high availability, we need to get one more server, few more 10 servers. So we have to create load balancers. So in this case, we have to create a 10 load balancers, 10 auto scaling groups. The reason, 10 different applications. We are not supposed to use same application for same server, right? So auto scaling groups are different. So 10 applications, we have created 10 servers to get a high availability. We are creating multiple servers, 10 auto scaling groups, 10 load balancers. So this architecture is very difficult to manage. The reason, if the applications are increasing, your network configurations increasing, network size is increasing. So the size of the instances are increasing. It looks like, very difficult network. It is going to be, extended. The network is very difficult to manage. Okay. Even though you are okay, no problem. We have created a 10 servers, 10 load balancer, 10 auto scaling groups. So to maintain this application as a high availability application, it's very difficult to manage that, the network configurations. If something is wrong in this any network, it's very difficult to find out. The root cause of the issue is finding is very difficult. The reason, multiple servers and multiple configurations, multiple auto scaling groups, multiple load balancers. And see, okay, even managing is very difficult. Also costing. Okay, so costing also very high, right? We are creating 30 servers. So if the more high if the load is more, the servers also will increase. So auto scaling cost, load balancer cost, multiple servers cost is very difficult to managing, right? So this is completely virtualization concept, guys. Cloud virtualization. If you're creating one EC2 instance, means the background, the server, they are running some physical mission, physical hardware. On top of the physical hardware, my EC2s are running. Okay. On top of my physical hardware, my EC2s are running. The physical hardware taking care by AWS Cloud. But here, okay, is there any option? So instead of creating multiple servers, is there any option to deploy 10 applications? So guys, we need to understand a very important thing here. These servers are running definitely somewhere, some physical hardware only. What is virtualization? By sharing this hardware, we are creating a VMs. So this physical hardware managing by AWS. On top of this physical hardware only, the servers are running. If you are creating a one VM, means this VM is allocating some hardware. So T2 micro, T2 medium, while selecting the T2 micro, T2 medium, the background, the instance resources are allocated on background on physical hardware. So this is host mission. You can understand this is host mission, host hardware. On top of that, VMs are running. Each instance is one VM. Okay, okay, fine. Oh, we are agreed that. But is there any option to run 10 applications? Is there any option to reduce this network configurations, the architecture? Yes, it is possible by using containerization platform. So this is virtualization. So this is virtualization. So we have a way to deploy 10 applications. So I'm taking one EC2, guys. I'm taking this line, understand here. I'm taking one instance from this line, one more instance from this line, one more instance from this line. So let me drag here. So I'm taking one instance. Okay, let's understand now. Okay, in this network, I'm taking 3 instances. Okay, let me take one instance first. This is my VM. One instance I'm taking that. One VM I'm taking here. Or you can take this VM, whatever, one VM is enough. So what is containerization? What is containerization? So guys, let me divide your VM, your server into 3 categories as we know. This is hardware. This is operating system. So here applications will come. But instead of deploying your application directly on VM, I'm not going to deploy application directly on VM. What we can do here? So on top of my OS, I will install Docker. So this is OS. So this is hardware. This is hardware. This is OS. So what we can do, Docker will create a containers, guys. Container is nothing but like a VM. Docker will create a containers. So better, guys, let me delete enter process once. Let me take a big VM like this in Broadway. Okay. This is one VM, guys. The first layer of VM is what? Hardware. And second layer of VM is operating system. And the third layer, I mean, its layer is nothing but on top of operating system, we are installing Docker. So just understand, Docker will create a containers. Container is nothing but kind of VM only, guys. So let me take this container one. Okay. One more container. Let's take container is also same like a VM. 3 layers we have. Okay, here operating system will come. Hardware. So same thing here. Okay. So let's take here. So Docker creating a container. We'll discuss what is container and all. But guys, this is single VM. VM means you can take EC2 instance. So single EC2, I'm deploying 10 applications. App 1 to app 10. How it is possible? Because of Docker. I mean, what Docker is saying that take a one VM on top of that install Docker. Just if you install Docker, we will create a containers. Each container host one application. So if you want to deploy 10 applications, we'll create 10 containers. If you want to deploy 100 applications, we can create 100 containers. But who will support for 100 containers? Who will support for 100 containers? Who will support for 10 containers? Here the point is, so this container is running, right? Okay, this container is running, but to require the hardware resources, it will take from host hardware. Same like virtualization concept, guys. Virtualization, VM will take hardware from host machine. Same. Docker container hardware will take hardware from EC2 hardware, but it will not share OS. It will not share OS from EC2 OS. Only hardware. So how many containers we can create? The question is how many containers we create? How many VMs can create on physical host mission? So till support your physical host mission, till support the hardware, we can create a multiple VMs. For example, your physical hardware supports to create 100 VMs, sorry, 10 VMs, I can create 10 VMs only. That is virtualization concept. What is containerization concept? Each VM, 10 out of 10 VMs, I'm taking one VM. Each VM, again, how many containers will support? Same. The containers, the number of containers depends on the hardware of your VM. So your VM will take hardware from physical host machine. Your container will take hardware from VM. So to understand the best practice, let me take a single diagram here. Okay, not here. Let me take a single diagram here. The layer, how to understand here. So this is just for example, you can understand this is a physical host machine. On top of that, you can create multiple VMs. Let's suppose I'm creating a 2 VMs. My physical hardware supposed to create 2 VMs. So these VMs, you need to understand either on-premises VMs or cloud VM. Cloud VM means EC2. So just understand this is cloud hardware. By sharing the cloud hardware, cloud is allowed to create a EC2 instances. Then what is container? Again, each VM can support to create a multiple containers. Multiple containers. This is the logic we need to understand. Okay. So this container, number of containers depends on the EC2 hardware. Number of EC2 depends on the cloud hardware. This is functionalities. Now containers are running on EC2 instance, EC2s are running on cloud hardware. Let's take this is cloud hardware or cloud host machine, whatever you can understand. Same thing. So what I'm trying to say here, to deploy 10 applications, not required for 10 servers, take a one server and install the Docker and create a containers. So we can focus later how to create a container, what is container and everything we can focus. The concept we need to understand here. Container and VM, both are same. VM and physical server, both are same. So VM and physical server, the difference is what? Physical server we can see, VM we cannot see, but both operations are same. Same. VM, container also same, but the differences are what here? VM also you can deploy your application, container also you can deploy your application, but the difference is here. Guys, this VM if you can take, minimum size is 8 GB hard disk, and the performance we can take T2 micron something, right? Minimum size is 8 GB hard disk. It is not possible to create 1 GB hard disk. Let's go and check here. So let's go and check here. So let's go to create a launch instance. Yeah. So the minimum hard storage, if you can go for storage. Yeah. Configuration storage. So if you can see, my configuration storage is what? Hard disk. My hard disk. So minimum size of hard disk is 8 GB. We cannot create 2 GB. It is not possible. If you create 2 GB, we'll get an error. Minimum 8 GB. Okay, anyway, we can discuss later. So why? Each instance is at least 8 GB, right? Each instance at least 8 GB. Now, okay, if you can take only 8 GB hard disk, you can extend up to 16 TB. For suppose if you can take only 8 GB hard disk. So how many containers you can create? How many containers we can create? So each container is 1 GB, for example, you can create 8 containers. On one EC2 instance, you can create 8 containers. Each container is 1 GB. or each container is 500 GB, you can create 20 containers. Or each container is 100 MB, you can create 100 containers. If you create, your instance size is 16 TB, so you can assume how many containers we can create. Okay, the number of containers depends on the size of the container, right? If it is a 100 GB size, 100 GB VM means we can create one container. So if you reduce the container size, we can create a number of containers on top of EC2 instance. But here we need to understand a very important point. So if you are increasing the size of hard disk and parallelly we need to increase the size of the EC2 instance, I mean type of the EC2 instance. So if you give more size but performance is less, it cannot access container will not give a good performance. So we need to create T2 from T2 micro 2, we have to increase it M5 large, C5 large to get more performance along with the size. Okay, I can increase instance type also to M5 large, and we can increase the size of the instance 8 GB to 1 TB. Okay, good. Okay, one EC2 is running fine, no? So you can create number of containers. So what is container here? Now we can focus here. So what is, if I take a one container here, for example, I'm taking one container example here. This is the container now. Okay. Simple logic. I'm taking one container here. Container means VM indirectly, hardware, operating system, application. Oh, sorry. Yes. Hardware, operating system, and whatever application you are going to deploy. This is container. So here, same like VM, guys. Same like VM. Compare with VM. Hardware, OS, application. This is VM. So here, to run my application, we need operating system hardware. This hardware will share from your EC2 machine. Same like. Container hardware, EC2 hardware. EC2 means host machine where Docker is running. Okay, perfect. So hardware step is clear. What about VM? VM can take hardware from physical machine. Okay, and container will take hardware from VM hardware. Okay, this is fine. Finally, container is running on hardware, VM. But what about VMOS? VMOS will give cloud, right? From AMI image. Cloud will give AMI image. Minimum size is 8 GB. If you take Ubuntu server, for example, minimum size you should take Ubuntu, whatever. Ubuntu AMI means minimum take 8 GB. Okay. What about this OS now? Container OS. Okay, VM OS we are taking from AMI. But what about container OS? Container OS will take from Docker Hub. Container OS take from Docker Hub. But VM OS take from AMI, Cloud Managed AMS. So this Docker Hub, okay, let's suppose this is also Ubuntu. This is also Ubuntu. So this OS minimum size is 8 GB. What about this size? You know, this size is 200 MB only. What is the difference here? If you create a Ubuntu VM, virtualization VM, minimum OS is 8 GB required. But if I create a Ubuntu container, Ubuntu VM, functionalities both are same. But Ubuntu, if you can take a Ubuntu image from the Docker Hub, the size is 200 MB only. Docker image. This is AMI image. Docker image. Docker Ubuntu image. Size is 200 MB. Minimum size. What about AMI image size? 8 GB. Both are Ubuntu's only. But the difference is here Docker Hub provided Ubuntu, no default dependencies, only Ubuntu dependencies. But this AMI contains a lot of dependencies. So guys, let's go. Let's go here. Let's connect here. Okay. So if you can see, this is for example new VM, mlist install grep. If you can give HTTPD. Okay. Python. Oh, sorry. So I haven't installed Python. Even Python is there. So if you can check like this, whatever, some default configurations already there. Some default configurations already there in your system. See git default configurations, Python configuration, some etc configuration. But I haven't installed, even though the M repository, some default configurations are there. Okay. So these many, if you can see, these many operations are running the background, but I haven't installed anything even. Still, these are the default configurations. That's what minimum size is 8 GB. So Amazon EC2, so Cloud EC2 will give with create an instance with minimum dependencies, even if you use or not. For example, just I want to create a EC2 instance to practice Linux commands only. To practice only Linux commands. Not required Python, right? But we don't have any options. We have to take minimum size is 8 GB. Even Python, if you can use Python or not, you need to take minimum size of the EC2 instance. If you use or not, you should pay for 8 GB cost. But if you delete all unnecessary dependencies, here, just wait. Hello? Urgent ఏమన్నా క్లాస్లో ఉన్నా నేను Okay. For example, if you delete unnecessary dependencies from your EC2 instance, so definitely your instance size also less. It is going to reduce. That's what Docker is giving here. If you can go Docker Ubuntu, just we can give. Let's go to Docker Hub. The size of the Docker Hub, if you can go for tags. See, minimum size is, oh, not 200 MB, even 25 MB. 25 MB only. See the size difference here. 25 MB and 8 GB. The differences. So if you can take this Ubuntu means nothing is there inside. Nothing is there means it will not run M command. It will not run apt command. It will not run tree command. No commands will be executed. The reason no commands require libraries dependencies are not there. This Ubuntu image, just simple Ubuntu image only. It's empty Ubuntu image. If you want anything, you need to configure. If you want to work with Python, you need to install Python libraries. If you want to work with Java, you need to install Java libraries. If you want to work with Git, you need to install Git libraries. Nothing is there inside. That's what size is very less. So what Docker is saying that simple logic, what Docker is saying that take empty image from me. Your application is Python, for example, just install Python dependencies. If your application is Java, just install Java dependencies only. I mean, we are reducing the size of your, the configurations. So not required much size of EC2 instance. Like that, you are creating a multiple containers on top of your EC2 instance. If you create a container with very less size, you can create number of containers on your EC2 instance. That is the motto here. Okay, let's understand, guys. Let's go to this process again. Yeah. See, this image size is only 20 MB, not only 200 MB. Okay, let's small logic here now. Let's go to here, small logic here. New paint. Okay. I want to deploy Python application. This is the requirement, guys. If you want to deploy Python application, okay. If you want to deploy Python application, we need a one server. Okay, I have created Amazon EC2 instance. So we have a hardware. So we have an operating system. And here you are deployed your application. So what is the steps here? First step is what? Create a server. We are using AMI image here. Okay. So for example, taking Ubuntu. Taking Ubuntu. Okay, fine. So Python application means I need to install Python. Second step is install Python. Third step is deploy code. Install dependencies also. Install any dependencies to run your code. Install Python, install dependencies, and copy code. Now run the code. These steps you need to follow if you want to deploy Python application on your EC2 instance. Creating a server means here you are taking 8 GB server. So creating server means we'll get operating system, we'll get hardware. Okay. So same process we can deploy in container. What is the process? We need a server, right? Server means we need a hardware and OS. So we are taking image from Docker. So taking Docker Hub, taking Docker Ubuntu image. The size of the image is 20 MB only. So here it is 8 GB. Okay, next. Your application is ready, right? What you need to do? Install Python. Only Python install. And install dependencies. And copy code. Copy code. So this is the process. And run the code. This is the process in container. So both are similar. No differences. But the difference is what? Size of the container. Here, many default dependencies are there, but here nothing is there. Take 20 MB, whatever you require install. Why installing Python? My application is Python code. That's what I'm installing, only Python. If you try to run Java, it will not work here. The reason you haven't installed Java here. Whatever you require, we need to install. So the process is now, okay, everything is done now. So this is called Docker file, guys. Simply, this is called Docker file. So if you build a Docker file, Docker build -t, give some name of the image, custom image, and give some dot. I will explain what is dot and all. If you run this command from this Docker file, we will get one custom image that is called Docker custom image, Docker image. So this image contains what? Your application plus dependencies plus OS. This Docker image contains. Same like a custom AMI. So after deploy your application, we can create custom AMI, right? So custom AMI is nothing but what? Dependencies plus OS plus dependencies. If you need this AMI, what you need to do? So if you want to use this custom AMI, what you need to do? Create a server from AMI. Custom AMI. So that you can directly access this server, no need to install anything, it will work fine. Application will come, OS also will come. Same like we are building a Docker image. This is AMI, this is Docker image. You are also taking here base AMI Linux Ubuntu 8 GB. After that, install the dependencies. After that, install a code, copy the code, run the server. It is working fine. From this, you are taking a custom AMI. Custom AMI means OS plus dependencies plus application. After that, if you create a custom AMI, if you want to use this custom AMI, again create server from custom AMI. You can access that server. No need to install anything. Inside application plus dependencies plus OS will come. Same here, taking a Ubuntu image, install Python, install dependencies, copy the code, run the code. Means whenever you execute this Docker file, you will get Docker file is nothing but instructions of whatever you want to do. So whenever you can execute the Docker file, you will get one Docker image. This Docker image is not a base image. This is the base image, empty Ubuntu. But if you create a Docker custom image, inside application dependencies OS. Now, if you run this image, custom image, so here we are creating a custom AMI. From the custom AMI, you are creating a server, right? Here we are creating a container. Docker run image, custom image. If you run Docker run custom image, we will get container will be created. We will get clarity once we do the practical. Container will be created. This container work like a server. It will run the application inside. So this container, we have a network, we can give access to public. Like that, we can create a multiple containers on top of our EC2 instance. So still here, till here, any questions? You can ask any kind of questions. This is very, very important concept, guys, Docker. Any questions?
As of now, clear, Veerav. Today we'll practice and I'll get you back to tomorrow.
Yeah. What about others? Any questions? Any confusion here? Just today you can understand what is containerization. Just leave it for what is Docker file, how to create image, how to create a container. Just we need to understand virtualization. The image size is more, large. Containerization, image size is less. So containers will run on Docker, on EC2 machine only once you install the Docker.
Veera, please can you repeat once again?
Yeah.
Not
Which one?
once. Can you give the overview of this?
Yeah. So instead of if you want to deploy 10 applications, instead of creating a 10 servers, we can create a 10 containers. Still here clear, right? Okay. How to create a containers? We just discuss later. Just understand. No need to create a 10 servers for 10 applications. One server is fine. On top of that server, if you install a Docker, Docker is able to create a required containers. 10 applications, Docker will create a 10 containers. Let's suppose to run a Docker, we need any one of the, just any server. That server is VM. I'm taking an example. For example, this is my VM. If I connect this VM, I want to deploy 10 application on this EC2 instance. It is not at all possible to deploy 10 applications directly on EC2 instance. So instead of that, what we can do, install a Docker. Docker will create a containers. That's it only. 10 applications, Docker will create a 10 containers. 100 applications, Docker will create 100 containers. But where the Docker will run, create any one of the server on top of the server OS, you can install the Docker. So I'm taking the host machine is EC2 instance. To run a Docker, I need any one of the server, right? So I'm taking one example EC2 instance. On top of the EC2 instance, I will install the Docker. To run a Docker, I need any platform. I'm taking EC2 instance as a platform. On top of the Docker, Docker will allow to create a containers. 10 applications, it will create a 10 containers. How Docker will create 100 containers? How Docker will create, we can discuss later. So, okay. Install Docker. Okay, my end already Docker is installed. Okay, my install already Docker is running. Let's check Docker version. Okay, Docker is running my end. Okay, so now what we can do, guys, I can create a containers here. You are, see, indirectly, if you create a containers means, if we can go here. This. Let me take. Just a minute, guys. Okay, see here. To run a Docker, I need at least OS. So I need a one server to run a Docker. I'm taking EC2 instance as an example. This is the entire EC2 instance. Yes, my EC2 is ready. I have installed Docker now. Okay, Docker is running on top of EC2 OS. Okay, what Docker will do? Docker will create a containers to host the application. How many applications need to create? 10 applications. So Docker will create a 10 containers. Each container is isolated here. Each container will get one network. So you can give this application access to public. You can give this application access to public. You can give, you can give, you can give, you can give. Same like if you deploy directly application on inside the EC2 instance, instead of installing the Docker, definitely you need to create 10 application, 10 servers. Why? Directly you are installing, you are deploying application EC2 OS. So we have to stick on one application, one application, one application, one application, one application, one application. So instead of deploying application directly on EC2 instance, we can install a Docker on EC2 instance. Here, I'm deploying containers. Each application one container. So here, okay, 10 servers if we can give public access, but we can give public access not directly server. We can create a load balancer. This two you can give public access. So this two we can give public access. Like that we can create. Okay. Now how to create a container? How to create a container? First, we need to write a Docker file. We need to create a Docker file. How to write a Docker file? Understand the requirement. So Docker file is nothing but number of instructions. So first to create a Docker file, first we need a one base image. Base image means what? Docker image. So same, if you want to deploy one application, Python application, we need a one server, right? Why server is required? Server gives OS, server gives hardware and deploy application. But I'm not taking EC2 instance directly. I need OS, right? Okay. I need hardware, right? Okay. So hardware will share from EC2 OS, EC2 hardware. OS will take from Docker Hub. We'll create a one Docker file. And here application instructions I can give. So Docker will build a one image. That image is called custom image. From that image, you can create a container. So when the container will create, how to create a container? Whenever you run an image, container automatically created. If you run the image, if you run Docker run image, container will create. Okay, Docker run image, container will create. Okay, which image you need to run? For example, if you run a base image, guys, base image, if you run base container only create, no application. But I need base image. On top of that, I will install dependencies. On top of that, I can copy my code and I can build so that image will be created again. This is custom image. If you run custom image, container will create it. But that container custom image means application plus dependencies plus OS will be there. If you run empty image, empty container will be created. So how to create a custom image? You need to write a Docker file. What is Docker file? You need to write some instructions. Take base OS, install dependencies. Which dependencies? Whatever application you are going to deploy. Python application means you need to install Python dependencies. Okay. Step number 1, taking base image. Step number 2, install dependencies. Step number 3, copy your source code. Step number 4, build your entire Docker file. Whenever you build a Docker file, custom image will be created. Whenever custom image is ready, whenever you can run a custom image, container will be created. This is custom container 1, application 1. Again, application number 2, create a Docker file for application 2. Which application it is? Java application. Okay, it is not a Python application. Okay, no problem. Take a base image. Step number 1, install Java dependencies. Step number 2, copy the Java code. Step number 3, copy the Java code means, so already after complete the Java code, we need to push it into the GitHub, right? Clone into the same repository. We are taking copy the code. Okay. Step number 4, build image. Which image? Custom image. And run a container from the custom image. Second container will be created. Same process, 10 applications, you have to write a 10 Docker file for 10 instructions. What are the instructions? See, whatever steps you are going to configure, the manual process, same steps we have to give in the form of Docker file. That steps configure means one image will be created including these all steps. Whenever you run that image, including all steps will be executed, create like a one container. Clear?
Yes.
Yeah. So what we can plan now, we can just practice some commands now. Meanwhile, we have some time. So we can install the Docker, we can practice some commands. So that we'll write some Docker file, not now Docker file, it will take some time. Meanwhile, we need to understand how to take a base image. We will practice some Docker commands. Then we can go for Docker file creation process. So before that, uh, if I go directly Docker file creation, may you confuse? So I will discuss manual process. If one Python application, how to deploy Python application on your server, same steps we can execute in the form of Docker file instructions. Docker can understand. Okay. So installation
Veera?
process.
Yes.
Yeah.
Veera, we are taking this EC2 instance, right? Is there any minimum requirement for the instance type?
You
Like
can
we are
take
take
T2 micro. You
data
can take
micro.
T2 micro. Yeah.
Okay.
Okay. Let me. Okay. I'll do one thing. Delete this instance now. So you will get clarity, guys, in 2 days. As this is first class on the Docker, it's not easy to understand. It's a microservices approach. Let's go to creation of launch instance. Docker. I'm giving just Docker name. Amazon Linux. You can take any key pair name. Problem. Take existing security groups default. Okay, launch instance. So click on the Docker here. Okay. The first command is to install a Docker install docker-y. So I'm not deploying application directly in EC2 instance. I'm installing a Docker. On top of the Docker, I am deploying my application in the form of container. So as container size is very less, so even 8 GB EC2 instance also we can create at least 10 containers. Okay. So how to start the container? Again, how to start the Docker systemctl. Start a Docker. If you want to check status, my Docker is active. So simply Control C here. Okay. So we just understand some basic commands. Docker images will check the list of images. Mine nothing is there. I'm going to take a one base image, base Ubuntu. Docker pull Ubuntu. If I run this command, one Ubuntu image will take. I will explain this command how it is working. And then again, you can check Docker images. See, one Ubuntu image is created with the 78 MB size. Okay. On this Ubuntu image means OS, Ubuntu OS. And if you run this Ubuntu OS, Ubuntu image, this will run. And to run this Ubuntu OS, we need some hardware, right? This the required hardware will take from EC2 hardware. Let's understand now Docker's architecture, how it will work. Simple logic here, we can easily understand. Yeah. This is base Docker architecture, guys. Okay. So here 3 categories are there. First category is client, interaction to Docker host. So whenever I will execute this command here, this is interaction. This is client. I'm running a commands means client. I'm interacting to Docker. This is client. Okay. Again, go to. Okay. You are running a commands inside EC2 instance. This is client. This request will go to first Docker host. Docker host is nothing but what? Whenever you can install a Docker, the Docker will run on your EC2 instance, right? So the Docker is run on EC2 instance. The request will go to first Docker. Okay. And Docker, the internally we have a Docker daemon. What is Docker daemon? This is entire controller of Docker. Whenever the request will give the Docker controller, Docker daemon. Okay, user is requesting Ubuntu image. Okay, this request will go to, it will redirect your request to Docker Hub registry. This is public Docker Hub registry. So it will pull the image from Docker public Hub registry. Then what is here containers and images? These are local path. So this is local directories. The local path of these images are Docker, where lib Dockers. Like Jenkins, where lib Jenkins, how it is? Like this where lib Docker means the Docker host, whenever you run a Docker pull image, first it will verify this image is locally available or not. Locally means first time whenever you run this image, the request will go to Docker daemon. It will verify local image will be there or not. If it will be not there, the request will be redirecting to public registry, and it will pull through local registry to client. Next time, if you can run again, the request will go to Docker daemon. Docker daemon will verify the image will be there or not. If it will be there, it will give back to you here. If it will be not there, it again will redirect into the registry. The first time runtime, it will take some time. The reason first time the images are not there, it will pull from central, Docker Hub registry. Next time if you run same command, it will not redirect the request to Docker Hub registry. It will take from local only. Docker Hub locally stored images, recent pull images. So if you can go Docker Hub registry here. So this is Docker Hub registry. Your daemon is redirecting to your request into Docker Hub here. This is the Docker. Okay. Not like this. Go to here. So this is Docker Hub. If you click here Ubuntu, sorry, yeah, this image only just now you pull this image only. Docker pull Ubuntu. Just now you pull this image only. So my EC2 is interacting with public repository through Docker daemon. Okay. So again, if I run Docker pull HTTPD libraries. So the request, this is client. The request will go to Docker daemon. Docker daemon will verify any image is there in the local. No, then it is redirecting into Docker Hub registry. Install the, pull the image. How to check the list of images? Docker images. See, my end 2 images are there. So like that, we can start the process. This is just only base images, guys. But custom images, how to create? We need to write a Docker file. In this Docker file, we need to add some instructions, and we can execute the Docker file. Custom images will be created. For example, if we're in a Docker run HTTPD. Okay. Docker run Ubuntu. Okay. So my end Ubuntu is running. Ubuntu is running means one container. Whenever I run an image, container will create. How to check the container? We can check Docker PS. Okay. So inside Ubuntu, okay, I will explain later. If I explain why containers I'm unable to see here, may you confuse. This is not a right time to explain this concept. Just understand till check the Docker images, how to pull the Docker image, how to install Docker. That's it only. Don't go for containers concept. I will explain in clear way tomorrow. So now this is the document what you need to follow, the Docker notes. So what is monolithic approach, microservices approach? Just Docker review, Docker images, containers, and installation process. So if you install your Docker on root, no need to execute these many commands. These commands is for if you install on EC2 instance. EC2 user. If it is a root, simply we can install. Let me delete this one. Install docker-y. Start the Docker if it is on root. So meanwhile, you just run the root. You just ignore this. These all commands you can ignore. You can check the Docker version. After run this, 3 commands directly go to Docker version. So here if you can see Docker -- version is Docker version. What is these 2 differences? So if I give Docker version, I'm able to see your Docker version. Sorry, the spelling is mistake, I think. Okay. Okay. Docker version. See, I'm able to see 25.0.5 is the Docker version. If you give Docker only version instead of -, it will show you your server and client interaction. Client means your EC2 is communicating with your server. Which server? Docker daemon. So whenever you run the Docker version, you are able to see client and server both. Only if both can run only, you are able to execute these commands, Docker pull and something. The reason this server indicates Docker host up and running successfully. If Docker daemon is only run, you are able to run What is Docker daemon? Controller for you between you and Docker. Okay, whenever you can execute the Docker pull, the request will go to Docker daemon. Docker daemon will verify the image is there in the local, or it will redirect into the hub registry. If you are unable to see whenever you run Docker version, if you are unable to see this server here, the Docker pull command will not work. So after install the install docker-y, don't forget to run systemctl start docker. If you run systemctl start docker only, we are able to see this one, client and server interaction. That's all for today, guys. Are you clear? So no problem if you're not clear, even though the coming classes you will get better clarity. This is a first class only on the Docker. This is same for everyone, not only you, even me also, when I was a learning time. So at least try to understand 5 to 10% only. Remaining 90% I will take care in the coming classes. Is it clear?
Yes, Veera.
Yes,
Yeah.
I have a doubt. Like when you
Yes.
run 2 times, like simultaneously, like if you run like Docker image 2 times, then you will get 2 containers at a time.
Yes. If you run 100 times, 100 containers will be created.
Okay.
But you may get doubt. 100 applications,
Yes.
if you run 100 times, 100 containers will be created. But here, each container, you need to allocate different ports, not in same port.
Okay.
To serve the traffic to external, we need to run containers on different ports. You will get clarity, guys. Not this time. You try to understand what is Docker. Simple logic only. Instead of deploying 10 EC2 instances, simply create one server, one EC2 instance. On top of that, install a Docker and start the process from tomorrow. That's it. Clear?
Clear, Veera.
Yes, it's clear.
Yes.
Okay. So let me share this to you till here only. Okay, guys. let me share this document to you. Okay. So tomorrow we can explain in details on the Docker. Okay. Thank you so much. Bye-bye.
Thank you.
Thank
Thank
you.
you.